Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I read the abstract of your report on how to integrate different methodologies in industrial problem solving. I'm really interested in learning more about your findings. Could you please provide an overview of the purpose and main ideas behind your study?
Of course. The purpose of our study on how to integrate different methodologies in industrial problem solving was to explore the effectiveness of combining multiple problem-solving approaches in industrial settings. We aim to identify how the integration of various methodologies can enhance problem-solving outcomes and provide more comprehensive solutions. The main idea behind our study was to acknowledge that no single methodology can address all industrial problems effectively. Different methodologies have their strengths and weaknesses, and by integrating them, we can leverage the benefits of each approach and overcome their limitations. We focused on 4 key methodologies: feedback loop integration, complex scenario handling, interpretation of results, and the use of an industrial chatbot for troubleshooting. By integrating a feedback loop, industrial experts can review and provide feedback on the model's outputs, allowing it to learn from mistakes and continually improve. This iterative process helps refine the model's responses, making them more accurate and tailored to specific industrial contexts. Complex scenario handling recognizes the role of human experts in dealing with situations beyond the model's learned patterns. Experts' judgment and experience are crucial in guiding the model through unprecedented problem-solving tasks, ensuring effective solutions even in complex or novel scenarios. Interpreting results involved implementing a system that generates technical documentation by processing engineering notes, specifications, and test results using a language model. This helps translate raw data into meaningful insights, facilitating the decision-making process and enabling better problem-solving outcomes. Finally, the use of an industrial chatbot for troubleshooting allows industrial data scientists to seek guidance and support from an AI-powered assistant. This chatbot can provide suggestions, recommendations, and solutions based on learned patterns and experiences, making problem-solving more efficient and accessible. In summary, our study explores how integrating different methodologies in industrial problem-solving can enhance the effectiveness and efficiency of solutions. By combining the strengths of each approach, we provide a more comprehensive and adaptive problem-solving framework for industrial settings.
Thank you for that comprehensive overview of your study. It's clear that the integration of different methodologies in industrial problem-solving can lead to more effective and comprehensive solutions. I have a few questions to delve deeper into your findings. 1. Could you provide an example of how the feedback loop integration methodology was applied in your study? How did it contribute to improving problem-solving outcomes in an industrial setting? 2. In complex scenario handling, you mentioned the importance of human experts in guiding the problem-solving process. Can you explain how the integration of human expertise and AI models improved the solutions in your study? Were there any challenges in incorporating human judgment into the problem-solving process? 3. The interpretation of results seems like a valuable aspect of integrating methodologies. Could you explain how the language model used in your study translated raw data into meaningful insights? What benefits did this bring to the decision-making process in industrial problem-solving? 4. Lastly, I'm curious about the industrial chatbot for troubleshooting. How was it trained to provide suggestions and recommendations? Did it rely solely on learned patterns? Or were there mechanisms to incorporate new knowledge and experiences into its problem-solving capabilities? Thank you in advance for sharing more details about your study.
In our study, we implemented the feedback loop integration methodology by establishing a process where human experts reviewed and provided feedback on the outputs of the model. This iterative process allowed the model to learn from its mistakes and improve over time. Here's an example of how this methodology contributed to improving problem-solving outcomes in an industrial setting. Let's say we have a manufacturing company that is using a language model to predict equipment failures. Initially, the model may have some inaccuracies or false positives, negatives in its predictions. However, by implementing the feedback loop integration, human experts can review the model's predictions and provide feedback on any mistakes or areas of improvement. For instance, if the model incorrectly predicts a certain component failure, the human expert can correct this prediction and provide the correct diagnosis. This feedback is then incorporated into the model, allowing it to learn from its mistakes and improve its accuracy. Over time, as more feedback is provided by the human experts, the model becomes more fine-tuned to the specific industrial context and domain of the manufacturing company. It learns from the expertise of the humans and adapts its responses to better match the intricacies of the problems encountered in the company's operations. By continuously integrating the feedback loop, the model's accuracy and problem-solving capabilities can be significantly improved. This methodology ensures that the model evolves and becomes more effective in solving complex industrial problems, ultimately leading to enhanced problem-solving outcomes in the industrial setting. According to the report, the feedback loop integration methodology was applied in various industrial scenarios, such as text-based equipment failure analysis and supply chain communication optimization, to improve problem-solving outcomes. The involvement of human experts in the iterative process plays a crucial role in refining the model's responses and making it more reliable in handling real-world industrial challenges.
Thank you for providing a clear example of how the feedback loop integration methodology was applied in your study. It's impressive to see how incorporating human expertise and continuously refining the model's responses can enhance problem-solving outcomes in industrial settings. Now, let's move on to the complex scenario handling methodology. You mentioned that human experts play a vital role in guiding the problem-solving process in situations beyond the model's learned patterns. Could you elaborate on how the integration of human judgment and AI models improved the solutions in your study? Were there any challenges or considerations in incorporating human expertise into the problem-solving process?
In our study, we found that integrating human judgment and AI models significantly improved the quality of the solutions. The human experts provided contextual insight and intuition that complemented the analytical capabilities of the AI models. This holistic approach allowed for a more comprehensive understanding of the industrial problem at hand. One of the key benefits of incorporating human expertise was the ability to navigate ambiguity and interpret vague or incomplete information. In complex problem-solving scenarios, the AI models may struggle to make sense of ambiguous situations. However, human experts can offer guidance and use their experience to fill in the gaps, leading to more accurate and practical solutions. Additionally, human experts played a crucial role in handling complex scenarios or novel situations that went beyond the model's learned patterns. Their judgment and creativity allowed the AI models to adapt and provide solutions in unprecedented problem-solving tasks. However, incorporating human expertise into the problem-solving process does come with its own set of challenges and considerations. One challenge is the need for effective communication between the AI models and the human experts. Ensuring that the AI models can understand and interpret the insights provided by the human experts is essential for a successful integration. Another consideration is the ethical aspect of problem solving. Human experts can contribute ethical considerations, cultural context, and moral judgments that may not be explicitly covered in the model's training data. This ensures responsible decision-making and aligns the solutions with industry standards and safety protocols. Furthermore, establishing a feedback loop where human experts review and provide feedback on the model's outputs is critical. This iterative process helps the AI models learn from their mistakes and improve over time. It also ensures that the solutions generated by the models are validated and interpreted by human experts to maintain accuracy and reliability. Overall, while there are challenges and considerations in incorporating human expertise, the integration of human judgment and AI models in our study significantly improved the solutions by leveraging the strengths of both approaches.
Thank you for providing a detailed explanation of how the integration of human judgment and AI models improved the solutions in your study. It's fascinating to see how the expertise and intuition of human experts can complement the analytical capabilities of AI models, leading to more comprehensive problem-solving outcomes. Now, let's move on to the interpretation of results methodology. You mentioned that a language model was used to translate raw data into meaningful insights. Could you explain how this language model was implemented in your study and how it facilitated the decision-making process in industrial problem solving? What were the specific benefits of using this methodology?
In our study, we implemented a language model to process raw data and translate it into meaningful insights. The language model was trained on a diverse dataset that included engineering notes, specifications, and test results. This training allowed the model to learn the patterns and structures present in the industrial problem-solving domain. The implementation process involved several steps. First, we pre-trained the language model on a large corpus of text data, including relevant technical documents and industry-specific literature. This pre-training helped the model familiarize itself with the language and terminologies used in the industrial context. Next, we fine-tuned the language model on specific datasets related to industrial problem solving. This fine-tuning process helped the model adapt to the unique language structures and terminologies commonly found in this domain. By fine-tuning the model, we ensured that it could accurately understand and generate text relevant to industrial problem-solving scenarios. The implementation of the language model brought several benefits to the decision-making process in industrial problem solving. Firstly, it enabled automation and efficiency in analyzing and processing large volumes of data. The language model could quickly extract valuable insights from engineering notes, specifications, and test results, saving time and effort for human operators. Additionally, the language model provided a standardized and consistent approach to analyzing data. By using the same model for processing different types of data, we ensured that the insights generated were uniform and comparable across various sources. This consistency facilitated better decision-making by providing a reliable basis for comparison and evaluation. Moreover, the language model helped in identifying patterns and trends in the data. It could analyze the text descriptions of equipment failures, for example, and extract commonalities that pointed to potential root causes. This analysis provided valuable insights for troubleshooting and preventive maintenance, enabling proactive measures to be taken to avoid similar failures in the future. Overall, the implementation of the language model improved the decision-making process in industrial problem solving by automating data analysis, ensuring consistency, and providing valuable insights for more effective troubleshooting and preventive measures.
Thank you for the detailed explanation of how the language model was implemented in your study and its benefits in the decision-making process of industrial problem solving. It's impressive to see how the model could analyze and process large volumes of data, provide standardized insights, and identify patterns and trends. Now, let's move on to the industrial chatbot for troubleshooting methodology. You mentioned that the chatbot could provide suggestions, recommendations, and solutions based on learned patterns and experiences. Could you explain how the chatbot was trained to acquire these problem-solving capabilities? Did it solely rely on learned patterns? Or were there mechanisms to incorporate new knowledge and experiences into its problem-solving capabilities?